Please go ahead, Leo.
Yeah, yeah. Um, Good afternoon and welcome to this user group session. My name is Leonardo Zuniga and I'm part of Bits.io, part of the professional services team. And today we will talk about Smart Store in Splunk. We will go through this agenda. We will cover topics like a smart store overview, some of the advantages of using smart store, um, the data ingestion process, as well the search process for data on smart store, some of the components like cache manager will be discussed in this session, and as well some migration considerations when implementing Smart Store. And as well, at the end, um, we can talk about scenarios of Smart Store implementation, any experience that anybody have had in the past. So let's get started. Um, so first of all, Smart Store is an indexer capability, right? That provides a way to use remote object stores. And these object stores are used to store data. Um, One of the main advantages of Smart Store is that it brings the separation of storage and compute resources. Um, some of the available storages that can be used are Microsoft Azure Blob Storage, Amazon AWS, and Google Cloud Storage. Um, basically, in Smart Store, or well, yeah, basically in Smart Store, changes the standard um, process of data storage, right? Because on non-smart store implementations, the file system is used basically for everything, for searching, for bucket processing, and basically for everything. With Smart Store, it's a shift on how Splunk works and operates. Because the data that is living on hard drives or network drives is no longer on disk. The data is no longer on disk. It is now on remote storages. As said, the main benefit of Smart Store is the separation of compute and storage resources, which provides in the indexing tier more elasticity. Um, the local storage on an indexer is now used as search. It's used for searching pretty much. And um, the buckets that are on SmartStore are in warm state. We will go in detail about the bucket process in SmartStore in future slides. When just a general overview of buckets, um, a bucket is where the data is stored. Buckets are located on the indexes, directories, and a bucket can be in hot, warm, or cold state. The buckets contain events from certain time periods and are an organized set of the indexing data. The buckets have Bloom filters, metadata, TSIDX files, raw data, which we will cover as well in future slides. This is how the SmartStore configuration looks when enabled. This is on indexes.conf. We define a volume which points to our remote storage, to the path. In case that we want to apply this to all of the indexes, we define the volume in the default stanza with the remote path key value. Some of the advantages of using SmartStore is that data is no longer tied to the hardware tier. Let's say on a scenario that with no SmartStore, if an indexer goes down, we lose a copy of the replication factor, which will cause cluster master to do some fix-up tasks that can take hours to resolve, will as well bring several warnings when searching. It will be not good when a peer goes down. But in SmartStore, this is different because the separation of the compute and storage, that each of these two resources can be managed independently. In case that a peer goes down, their recovery from failure takes few minutes or even seconds, and data is safely stored in the remote storage. And as well, another advantage is that it reduces the need for extensive and sometimes expensive on-premise hardware on large deployments. When getting data in SmartStore, it's a bit different than when it's not enabled. Here we see a normal or classic architecture where data comes into Splunk. The data goes through each of the bucket states, and once it hits retention policies, the data is either deleted or kept on frozen state. In SmartStore, this changes. Here we have an example of an indexer cluster. By the way, before going here, does anybody any question or something or anything?
I'm good, yeah.
Nice. So when we get data in on an indexer cluster where SmartStore is enabled, the process will be like this. The hot bucket is just the same as usual. Data arrives to the Splunk deployment. Bucket receives new events, and then when the hot bucket streams to the cluster peers depending on their replication factor, and when the replication is complete, the buckets move to warm state. That the change of bucket state is as well defined by the retention policies. At the time when the bucket is in warm state is when it's uploaded to the remote storage. And this process is done by the cache manager. So the cache manager detects the warm bucket, it uploads it to the remote storage. The cache manager is on indexers. So the source peer, when the bucket is uploaded, the source peer notifies the remaining peers in the cluster that the bucket was successfully uploaded. So the remaining peers will not attempt to upload the bucket to the remote storage. If there is a case, let's say in a scenario about that the source peer goes down before safely sending the bucket to the SmartStore, the target will have a timer to know or to receive the message from the source with the successful upload. If that never happens, the next peer checks the remote storage to double check if the bucket was uploaded properly or not. Yes, basically this is how the in an overview on how the data flow goes on an indexer cluster with SmartStore enabled. What happens when we search or when a user searches for this data? So when buckets are in hot state, it's just as normal. A search request is received, indexers generate the list of buckets needed to display the events, and it's just as normal. For cached buckets, the cached buckets are buckets that are in warm state, but that are not evicted yet. We'll cover the eviction in a couple of slides, but when searching for cached buckets, the search process opens the bucket with the cache manager. Cache manager informs to the process that the bucket contents are, let's say, locally and available for search, right? But the main change or the difference when searching is when we search for remote buckets, because these remote buckets, what the indexers have is not the entire bucket contents, are just pointers or the metadata of the buckets and nothing else inside the bucket. So when we search for a remote bucket, which is in the SmartStore, the search is processed, the cache manager realizes that it is not in cache, the search process waits. It's not that it's done in seconds, but the search process waits, and then the cache manager fetches the bucket from the remote storage. When the contents are fetched, uh, well, the bucket is then local and available for searching. Then, once there's something key and it's important that the cache manager, when it starts the process of bringing the bucket from the SmartStore, this process, it's called localization process, right? So again, when the bucket is localized, it brings it to the cache state with this with the bucket files that are needed. And then when search finishes, the bucket it's read and it closes it. There is a reason on why a bucket is opened and then closed. And that's because indexers have a count of how many searches are actively using the buckets. The idea with this is that if a search is using a bucket, but that bucket is not yet closed, is because other searches are using the bucket as well. So will not make sense for to download the contents over and over again, to throw the downloaded contents and then bring it back for another search. We can see all the buckets that were opened and closed in the Splunk D access.log in case that you want to see which buckets were opened and closed while the while searching for remote buckets. Any questions so far?
No, Leo.
Okay, cool. Something really key in SmartStore is the cache manager. That, as said, its main function is to localize data, to fetch specific bucket files. Again, the buckets have Bloom filters, journal, metadata, TSIDX files. But why it fetches specific bucket files from the remote storage? Let's say that we run a tstats search, and a tstats will only need the TSIDX files, right? So there's no need to download the entire bucket contents. Same if we run maybe a metadata, or even if we run an event count or DV inspect search, which will not need the bucket contents, right? When the cache fills up with the buckets that are in cache, the cache manager performs an eviction process, which is pretty much uh, taking buckets away cache, right? Cache manager also performs a look ahead function, which means that the cache manager pre-fetches or pre-downloads buckets needed for searches. So when a search runs, it will process hundreds or X amount of buckets. So going one by one will not be really efficient. So the cache manager will go ahead and fetch if I'm not wrong, is 10 buckets by default. So it will be prefetching buckets. And let's say that we want to see which contents were downloaded for a particular bucket. We could look at these files by checking the cache manager local.json. Let's say that a search downloaded the tsidx files. We'll see a tsidx entry in cache manager local.json. Now, as said, the eviction is when cache manager had a bucket, but then no search is using that bucket, so it evicts the bucket contents. And that is when indexers will have the pointers or the metadata of a bucket. So by default, the cache manager, there are some policies. Let me show you the policies. These are the policies. By default, cache manager uses the LRU policy, which evicts the least recent used bucket, right? So warm buckets are not immediately evicted from search. The way eviction goes or works is that the oldest bucket that has not been used for search and maybe the cache is going out of space, that is when the eviction process. So it detects a very old bucket that nobody is searching for it. That's when it evicts the bucket. Cache manager will attempt to keep buckets that contain events with timestamps from the last 24 hours. But that as well depends with the if the cache is going out of space, right? When a search is run, what goes first to the remote storage is the Bloom filter of a search. So it knows which buckets to search and which to exclude. And tsidx files and journals are typically evicted quicker than the other files, like smaller files that are as well that the cache manager attempts to keep these smaller files for 15 days. These are settings that we can manipulate on server.conf, but these are typically not modified. If modification is needed, we can always do that, but we need to double check documentation and if possible, check with Splunk support in case that any impact happens after change. Now, when SmartStore is enabled on a deployment, we would like to maybe monitor how it's behaving, the activity on the bucket, either upload or download. So we could use the monitoring console, which has SmartStore views on our deployment, right? The SmartStore dashboards have activity dashboards that are related to the remote storage and provide us information related to connectivity to the remote storage, activity related to the upload and download of buckets, same as if there are failures, right? on the upload or download. It also provides a view of the cache performance, which provides information about the bucket eviction rate, the values of server.conf, if there are multiple attempts to download a bucket, things like that. So if we have SmartStore running for our deployment, monitoring console, it's always a good resource for monitoring this remote storage. Now, there are some considerations when planning to migrate to SmartStore. So first of all, as we saw on, I'm moving back to this slide. As we saw here in the indexes.conf, we will have the remote storage configuration, right? And if we want to apply the remote storage for all buckets, we can go with the default, we can make use of the default stanza. But what if we don't want to enable it globally? Well, that is when we can plan to have maybe a list or determine which indexes are going to have this solution, right? So we can enable SmartStore by bucket and not all across the indexer cluster. Something to take in consideration is that while migration is running, let's say we have a well, the standard storage, which will be local, and we want to move to SmartStore. While that is in progress, it will impact our deployment, mostly the search. So it's not that the searches or that you cannot run searches. You can run searches, but you can experience a slower returning of events, and as well maybe a warning in the search UI. So that is important. So if you are planning to migrate, maybe it can be in place when there are less users using the Splunk deployment, when maybe there are not too many saved searches running. So that's important to think about. And to monitor the migration progress, we have these two search queries, which will provide details about the status and information about how the migration is going. And in summary about SmartStore, SmartStore, as said, is a remote storage available for Splunk indexers that the SmartStore stores the master copy of warm buckets, right? The cache manager resides on indexers, and the cache manager is what's in charge of doing all actions related to warm buckets. Remember that when a bucket is uploaded to SmartStore is when it's in warm state, because it doesn't changes or is not receiving new events as when it's in hot state. Um, Cache Manager as well calculates buckets participating in searches and which buckets are expected to be used. So it can evict, well, yeah, it evicts buckets or fetches buckets based on the searches. So Cache Manager uploads warm buckets to the remote storage. It fetches buckets or specific bucket files from the remote storage and evicts buckets from the local cache. And the eviction, again, it's based on the bucket age, how frequent the bucket is used, and as well how um, big the bucket is. But most of the times it's by age or how frequent they are in use. Um, Indexers, as they no longer store the bucket, the entire bucket contents, they store instead a copy of the metadata from the remote storage. Here we have S3, GCP, but it can be any of the remote storages available. So indexers, disregarding which is the storage in use, it stores a copy of the metadata. And as well, they store hot buckets. The metadata or pointers, they have all the information of warm buckets. And on an indexer cluster, what is replicated across the peers is this metadata information, right? If one of these peers goes down, there is no data loss because the buckets are in um, the remote, right? And depending on how large is the deployment, it also offers a benefit of being maybe cheaper than expanding or getting more servers in the deployment. Um, so this was the session about SmartStore. I'm not sure if anybody has a question or wants to share any SmartStore scenario that or issue that you have experienced with, or anything that was not clear.
No, Leo, I didn't get chance to work on this smart store, but I practiced it on my local server.
Of course. Remember that SmartStore is available for Splunk on-prem or even Splunk Cloud,
Yeah.
right? So yeah, if there are no questions, I just want to say thank you for joining to this session.